Good morning. So today also we will be just concluding the chapter on the projection of planes. So if you just remember from the past 3-4 classes, we are solving problems based on oblique planes, wherein the plane is inclined to both HP and VP. And while solving those problems, we would have seen different cases. The case one, what we have seen is, if we just recollect, we have just considered the surface inclination of the lamina with reference to HP and the side inclination is with reference to VP. That is, we considered case 1. Then we considered case 2, wherein in case 2, we considered that the surface of the lamina is inclined to VP, but one of the sides of the lamina is inclined to HP. That is the second case we considered. And also if we just recollect, whenever we give surface inclination and side inclination, we need to satisfy first the surface inclination, that is after doing the first and second stage, and in the third and the last stage, we are going to satisfy the side inclinations. Okay, so that's what we did, case 1 and case 2. Then also we considered such that the lamina true shape is given in a particular view itself. For example, if you just remember in the previous session, what we did was, we have a rectangular lamina, wherein the lamina is seen as a square in the front view. So that we say that instead of giving directly the inclination of the lamina with reference to VP, we would have given that in the front view it is seen as a square. So that indirectly I have given that the surface is inclined to VP. So that also we did. And also the other case what we did also was, wherein the sum of the inclination of the lamina can be 90 degrees. Because as you have seen the problems what we have done, even though in the last stage I told you that the lamina is inclined to both the planes, but since in both the views we are going to get some smaller sizes, because anyway that is the indication to say that the lamina is inclined to both the planes, but the sum of the inclinations need not be 90 degrees. So let us say, if the sum of the inclinations with reference to HP and VP is 90 degrees, I think I have done one problem wherein the lamina will be seen as a line in the side view. That is, in the side view it is seen as a line. Since it is seen as a line in the side view, I can conclude that sum of the inclination with reference to HP and VP has to be 90 degrees. That is the reason we can also do such problems either starting from side view directly, or I can just do it in the regular fashion. Is it okay? Now today I am just going to demonstrate one more problem wherein I think we can start from side view. Or this particular problem what I have just indicated here can also be done in the regular method also. So regular method means I need to do 3 stages. If I want to do my side view means directly draw the side view. I will just in a single step I am going to get the final views. Okay, let us see this problem. We have a pentagonal lamina of sides 30 mm is resting on one of its sides on HP and with a corner opposite to that side touching VP. The side is parallel to VP and the corner touching the VP is at a distance of 20 mm from the HP. Draw the projections and determine the inclination of the lamina with reference to the reference planes and also distance at which the side is from the VP. So if we just read this problem, we can see that I have never mentioned any surface, the inclination is not at all given. That is, I have given these inclinations, I can say indirectly. And again, as you can see here, how do you start? Because always that is the hitch now. Okay, anyway it is given that it is resting on one of the sides on HP. Let us say if I demonstrate this. Okay, so let us say if I consider the lamina in this way, let us say I will start from front view. If I start from the front view, I will first draw the lamina in this way, such that one of the side is resting on HP itself. I can just indicate like this. Okay, that is my first figure. Next figure what I need to do? Next I need to see that the corner opposite to this particular side should touch VP. That means it should incline like this. Not only that, instead of giving this inclination with reference to HP, what I have given? I have given that the corner opposite this particular side is at a distance of 25 mm. For example, if this is my VP, I would have inclined in this way. Is it okay? Inclined in this way such that this particular apex point should be at a distance of 25 mm or 20 mm from HP. So I have written like this. So this is what I wanted. But as you can see, since if I consider in this way, then I bent it. What will happen? Now this is what I wanted. Finally what I wanted to show that this particular lamina is parallel, one of the sides is resting on HP and the corner is touching VP. So once I do in this particular fashion, now we can observe carefully. If I see the side view, in the side view, the lamina is seen as a line. Since the lamina is seen as a line, I can start from side view method. Okay. For example, let us say if the lamina is something like this, then I cannot start from side view. That is to say that the sum of the inclinations will not be 90 degrees. That is one method. That is starting from side view method. Let us say if I want to do a regular method. Regular also I can do. How do you do by regular method? Now again see this problem. I have just given that a pentagon of 30 mm resting on one of the sides on HP. So if you just remember, I used to say that whenever I say that one of the side is resting on HP, that particular side should be taken perpendicular to VP. So where do you get that VP details? In the top. So I need to start from top. So maybe I will start it like this. You can see this demonstration also. So I will first start like this. Then what it is given? It is given that the corner opposite to this particular side is at a distance of 20 mm from HP. I will do like this. Second stage. What about third stage? Third stage is instead of giving with reference to a particular side, what I have given is this particular corner is touching VP. Then what you do then? I am going to redraw the figure like this. That is the third stage I am going to draw in this way. So once I do like this, then you can see the lamina is getting inclined to both HP and HP, because as you can see in the second stage, lamina is still inclined to HP, whereas it is still perpendicular to VP. Once I made this corner touches VP, so remember we are going to redraw. Why are going to redraw the figure? Because since the surface inclination remains constant, that will be HP now. Since that remains constant, the shape remains same. Since the shape remains same, I want to satisfy only the other detail. To show that, I need to simply redraw the figure. Is it clear? So as you can see, either I can do this problem by regular stage 1, stage 2, stage 3 method, or I can do by regular, or I can do from side view method. So I think I will do this particular problem by side view method. Is it okay? Okay, now whenever I want to do by side view method, always I will consider that lamina to be parallel to VP. Is it okay? So draw the XY line. Okay, anyway, now I wanted one of the side of this particular pentagonal lamina should rest on HP. So what you do then? I will consider the one of the sides here itself. I will say one side. Is it okay? Then I will complete the pentagon. I just drawn the pentagon. Then as usual name them. So we know that I should name from the leftmost visible point in the clockwise direction. Since I consider lamina like this, how it will be seen in the side view? It will be seen as a line. Even in the top view also it is seen as a line. Okay. So since it is seen as a line, first I will consider that. Okay. So how do you see here? This is my original lamina in the side view, which is seen as a line. So again get the points here. So I will write A double dash, B double dash, C double dash, D double dash in brackets. Then we have P double, because anyway for the observer I can see A, B and E I cannot see, because anyway this is my x1 area. As you can see, still I have not written. I have not drawn the x1 line. I will tell you why I have not drawn it. Otherwise, you know that whenever I want to draw the side view, first I need to draw this x1 line also, but I have not written, and you can see why I have not done in another 2-3 minutes. Okay, now what about the corresponding, how this particular lamina to be? I told you that lamina is seen as a line in the side view, but I wanted to show that this particular lamina, one of the side to be an HP. So you know that in the side view, this OY represents HP, whereas OX1 represents VP. Now what I wanted that this particular lamina, anyway this is a side. So this is the opposite to this is corner. So this corner should be such that it should be at a distance of 20 mm above HP. So again I can just draw the locus of 20 mm. Okay, so let me do that. Let us take some 20 distance. Then I am going to draw this line. So this distance how much, as I said, this is 20 mm. Then what I should do, I know that this particular corner B has to be at a distance of 20 mm above HP. So then what I need to do, that in the side view, the lamina has to get inclined. Okay, so once I incline this lamina, then you know that in the side view, I can see both HP as well as VP. Remember, you know that always in the top view, in the front view, we see only HP details, whereas in the top view, we see VP details, whereas in the side view, we see both the details. Okay, so now what I do is, I am just going to incline this such that this corner I am going to rotate like this. So please tell me whether I have to rotate like this or like that. Which is the correct for this particular problem. Now anyway it is given that this corner opposite particular side is in VP. So in VP means what? That is, once I draw this x1 by 1 line, this particular point should touch there only. Let us say if I incline like this, what will happen? That's what I said now. See, for example, I have started like this. If I incline like this, then this corner is coming closer to VP, or the one case is it can simply touch it. But if I incline other way, what will happen? That means this particular corner is away from VP. But anyway, I wanted this corner to touch VP. So obviously, I need to rotate in this particular direction. That is, what I want to do is, I am just rotating in this way. So I am just doing it graphically. Okay. So let us do that. So I will take this length. Then this length should be equal to this length. Is it okay? So this is your new position of the lamina. New position of the lamina. Okay, what about this point? So this point also will move like this. That is, I am going to draw another arc like this. I think not this. I think I need to do for this. Okay, now I can just get these points. So what are the points again? This point has to be B double dash, this has to be A double dash and C double dash, and this point is here only. Okay, now what I wanted this corner to be 20 mm, not only that, it should touch VP. So since it has to touch VP, I need to consider this x1 by 1 line, because we know that OX1 itself is VP in the side view. So now what I do then? I will draw a line here. So what is this line now? You know that this is xy and this line has to be x1, y1, this is O. As you can see, if you have written this particular line initially itself, anyway I don't know at what distance, even if you rotate at what distance this particular point will come. Then you may have to again redraw this x1 y1. That is the reason we know that this particular corner to touch on VP, not only should 20 mm. So it is only a unique solution. Is it okay? Now I need to draw the corresponding top view and front view. Okay, now let us write the original top view. Original top view means I am just going to draw this top view when it is parallel to VP. When it is parallel to VP, it is seen as a line here. How it will be seen in the top view? Top view also seen as a horizontal line. How do you get this? I will get this by the procedure. What is the procedure? Wherever we have the top view, I should draw this 40 degrees line. The purpose of drawing this 40 degrees line is to transfer the VP distances. Whereas HP distances we are transferring from front view. That is the reason we used to say that your side view should be in line with front view. So this is 45 degrees. Okay, so let us get this. So this is my original figure. Original in the sense when it is parallel to B. A, B, C, D, E. Now the lamina has been inclined. Now I wanted to determine the inclination of the lamina with reference to reference planes. And you remember always that the surface inclination of the lamina will be shown in that view wherein it is seen as a line. Where it is seen as a line now? It is seen a line in the side view. So obviously this particular angle indicates with reference to HP, that is theta, which we need to measure, and says it is seen as a line in the side view. We know that this angle has to be 90 minus theta. So I will write this as what angle then? Fine. So I need to measure this two. Okay. Not only that, you can also see I wanted to, and I have given one extra statement here. The side is parallel to VP. It has to be parallel. As you can see, this has to be parallel now. You can just say it is parallel to VP. As you can see, this is seen as a point. Seen as a point with reference to this OX1, it has to be a line parallel to OX1, that is parallel to VP only. So this particular statement is actually I give an extra statement. Even otherwise, it is parallel. But not only that, I need to determine the distance at which the side is from VP. So what I need to measure then? I need to measure this distance also. So this distance is a X. So what is X here? X is the distance of this particular side DE from VP. Okay, now anyway everything is set. Now finally I need to draw the new top view in front. Why new top view in front view? Because the lamina is inclined to the HP as well as VP. Okay, anyway I think let me start first doing this view. Okay, anyway this particular point is here. So I will draw the projector. Okay, so let us see the projector through B. Where is the projector from B here? This one. So how do you get it? Intersection of those two. So this point is what point then? B dash. Okay. Similarly, I need to get these points. Let us see this. I am just going to draw from this A dash and C dash. Where is A dash? A double dash is yes. A dash is here. So the intersection is your new A dash. Similarly, C dash, C double dash. This is your new C dash. Okay, what about your D and A? Because it is on VP itself. I mean it is on HP itself. Okay, now I can join the points in the same proper sequence. So what are the sequence? A to B, A to B, and B to C, C to D, D to E, E back to E. See, this is my new front view. Okay, what about the new top view? Same procedure. What is the procedure? See, anyway, these two will be here only. Your D and E here only. Okay, then let us say I want to get this B. Where is B here? So B is touching VP. Now since it is touching VP, I need to draw the projector through that. Okay, that is, its VP distance is 0. That means I need to draw a line like this, draw a line like this. This is your B dash, because remember, B dash and B should be on the same projector. So where do you get that? I will get here itself. This itself your point P. Why point P is here? Because its VP distance is 0. That is, it is on this O itself. That is the reason. Because anyway, I wanted this point, this corner to be in VP. So what do you get corner in VP? Its top view should be on XY line. That is B. Okay, now I need to get this A and C. So what do you get A and C? So draw this projector. So So draw this projector. So this is for A and C. This is A dash. So this should be what then? A. This is C dash. So this should be C. Okay, what about your D and A? Already D and A only. So D, E here itself. Then what you do then? I got all the points, join them in the same proper sequence. That is A to B, B to C, C to D, D to E, E back to E. Is it clear? Now again I am just going to demonstrate this, whether this is correct or not. Anyway, I told you that I started like this. Then I have just inclined in this way. Okay, so once I incline like this, if I see from here then, so this is on XY line, this is on XY line, then this corner will be at what distance? 20. If I look from the top, what about this? This should be on XY line. Then I am going to elevate this particular line is parallel to VP. At what distance? X distance. So I can just measure it. So as you can see, this problem, I think I would have done in a very simpler way if I do this problem by side view method. If you feel, no sir, we got confused, don't worry. You start like this. That means say that anyway wanted one of the side to be parallel to HP now. So initial that particular side will be perpendicular to VP. That means they have to start from top view. So start like this. Then in the second stage, lift this so that this is a distance of 20 mm. Third stage, what you do, instead of giving inclination, directly I said that this particular corner is touching VP. So what do the third stage? Third stage, redraw this figure such that I am going to get like this. Then I am going to get the final figure. Is it clear? Thank you.